to go over the multi-digit division. So here's what we do. We do daddy, mommy, sister, brother, dog. So we're dividing first, and we're dividing this first number right here. How many times does 5 go into 8? It goes in 1 time. Now we multiply. 1 times 5 is 5, and then this isn't really here. I just put it there so that we were just showing that we were just dividing 8 by 5. Now our next step is to subtract, so we subtract 8 from 5, which is 3, and then we BD, bring down the 6. Now we go back up to D, division. We say 5 goes into 37 how many times? 7. Now we multiply. 7 times 5 is 35. Now we subtract. 36 minus 35 is 1. And then we bring down the 8. Now we go back up to divide. 5 goes into 18. How many times? 3. And then we multiply. 3 times 5 is 15. Now we subtract. 18 minus 15 is 3. There's nothing left to bring down. If there is a number here, we put it up here as our remainder. We write R3, or it could be a 0, and then there would be R0 or no remainder. If it's R0, we do not have to put anything. We just leave it as 173. This one is 173, remainder 3. So I'm going to give you some to do. Some of them are going to have remainders, some of them are not. Okay, so those are the 4 that I want you to do. The next thing we're going to do is something called prime factorization. I think it's pretty fun, actually. So what you're going to do is you're going to make a prime factorization tree, and we start with a number. So I'm going to start with 90, and we're going to think of 2 numbers that when multiplied together equal 90. So an easy one is 9 and 10, right? And then we go to the next set of numbers and we say what numbers when multiplied together equal 9. Well, I know a set, 3 and 3. What are 2 numbers when multiplied together equal 10?
1 and 2.
All right. Now we say what numbers go into 3? Well, the only factors that go into 3 is 3 times 1. There's no other way to make a multiplication sentence to equal 3 except for 1 times 3. As soon as we get down to where the only thing that goes into the number is 1 and itself, we call that a prime number. There's no other numbers that can be divided into it. That's why it's called a prime factorization tree. We're factoring down in a tree until we get to all prime numbers. So 1 times 3 is the only way to make 3. 1 times 2 is the only way to make 2. And 1 times 5 is the only way to make 5. So we circle them, and we know the circling tells us that we're done finding factors, and then we write them in order from least to greatest. So our least number is 2, then our next least number is 3, then our next least number is 3, and then our greatest number is 5. And then we make a dot like this. This means multiplication. So there's different ways we can show multiplication. One is like this, 2 times 3 times 3 times 5, which you can totally do. But when we're doing prime factorization, this is how it's usually written. And it means the same exact thing, so you can do it either way. I am 100% fine with that. Sometimes the factor trees are small, and sometimes they're big. So for example, if I had a factor tree of 9, then I would just do 3 and 3, and now I'm done. So the answer would be 3 times 3. Some of them are bigger, some of them are smaller, but you keep going down until all of your numbers are circled, and they're circled when they only have one in itself that go into the number. Does that make sense to you, honey?
No.
Okay, so I'm going to have you do some of them, have you do 4. So we're going to do 25, 12, and 65. And a little hint is whenever a number ends in 5, we know that 5 is going to be one of the numbers that we could figure out, right? If a number ends in a 0, or a even number, we know that we could always use 2. It doesn't matter what number you use as long as you use numbers that go into them evenly. Does that make sense?
Yeah.
All right, awesome. The next thing we're going to do, which is similar to this, is we're going to find what's called the greatest common factor, or GCF. You probably remember doing this last year. Maybe it'll come back to you.
I think I learned that in 2nd grade.
Yeah, you learn it in 2nd, 3rd, 4th, 5th, 6th, and 7th. Same stuff. They just go with bigger numbers. So if I asked you what the greatest common factor of 12 and 18 are, it's kind of like we're doing a prime factorization tree, but we're not putting it in tree form. We're just putting it in a row. So what are the numbers that go into 12? Does 1 go in? Yes. Does 2 go in? Yes. Does 3 go in?
I'm confused.
What?
Is this what you're showing me right now, homework?
Yes.
Okay.
I'm making a video too. Does 5 go into it? No. Does 6 go into it? Yes. Does 7 go into it? No. Does 8? No. 9? No. 10? No. 11? No. 12? Yes. And then we make a rainbow. So we match the factors. 1 and 12 go together. 2 and 6 go together, and they all equal 12, right? If I don't have a match for my rainbow, it means I'm missing a factor. But there is something that is an exception. The exception is when it's a double. So if I was doing the greatest common factor for 16, I would write the factors out, and then I would try to match them. And then you see here, 4 doesn't have a match. It's because 4 times 4, so we just don't write it twice. So I just make a U like this, meaning 4 times itself is 16.
Okay.
All right, so that's the first step. And then the second step is to find the factors of 18. 1, 2, 3. You just ask, does 4 go into it? Does 5 go into it? Does 6 go into it? Does 7 go into it? Does 8 go into it? Does 9 go into it? Does 10? Once you get to the halfway point, you can close it off with the number. Now,
Okay.
the third step is to find the greatest number that they have in common. So they have a 1 in common, a 2, a 3, and a 6. 6 is the greatest number. Okay. So for homework, you're going to do the greatest common factors of 25 and 40. You're going to do 24 and 40, 14 and 35, and 4 and 12. And then we're going to practice our...
14, 35, and what?
You'll see it on the video. And then practice your multiplication facts. So the strategy for times 12 is to break it into a 10 and a 2. So 10 and 2, 10 and 2, 10 and 2, 10 and 2, and then all you're going to do is take it times that number. So 10 times 11 plus 2 times 11 times 7 times 7 times 6 times 6. And then I'll use this one as an example. 10 times 6 is 60, and 2 times 6 is 12, and then you add these together to equal 72. All right, my darling, have a wonderful week. I will see you next